Good morning, third period. We're into the statistics unit, and I want to talk about study types today. Okay, so study types is it's a crossover with science and math. So please add your name here. So if I find one in the room, I can get it back to you, and I'm going to put in today's date somewhere too, so I can put these things in sequence when I do some studying. So add today's date and your name. I have 3 related topics. And here at the top, I'm going to write the phrase. Let me zoom in for you. So that I'm in the top circle, and I'm going to write in statistical studies. And then we will talk about 2 kinds of statistical studies. Okay. Statistical studies, well, they study populations. And I'm going to leave that very vague, because it could be a population of viruses in a dish. It could be a population of bears in the mountains. It could be a population of human beings that are receiving medicine. Statistical studies study populations. That's the numbers that we use that represent a measurement on a human being or the number of bears in a forest. Okay? We collect samples. So it's very rare in statistics that you would sample everybody in a population. There's over 6 billion people on the planet. It's too expensive to get information from all of them. So we would study a sample. And the sample is bound by the rules of statistics. We collect samples, then analyze data using statistical math. So essentially, scientists are mathematicians. They have to be responsible for getting the math side of the equation correct. If you follow a rigorous plan with your statistics, then you make conclusions. And you don't just make conclusions about the sample, but you make conclusions on the population. So think about it. I'm going to study all the humans on Earth. I'm only going to take a sample of them. And if I follow the rules of statistical math, my sample lets me make a conclusion about all humans, or all students in third period, or all students in Mr. Mitchell's math classes, as we've done in the past. We have done statistical studies in this class. You've seen them happen. I'm going to break them into 2 categories. One is observational. Okay, observation. So to observe something means to watch it. There's an observational study, and then there are experimental studies. And you guys might see a nice crossover with things you've done in science before, because science talks a lot about experiments. I'm going to draw a line under mine so I can see that I have terms and definitions. Observational studies and experimental studies are 2 kinds of statistical studies. They follow a generally different set of rules. Let's start with observational. Studies may draw conclusions even though variables are not controlled. And I'll tell you more about controlling variables here in a second. But in observational study, you can draw statistical conclusions even though your variables are not controlled. Scientists will observe. So there's a clue. If you see the word observe, they will observe patterns in math, then make conclusions. Okay. Nice job, team. We're almost through it. In an observational study, I might go into the Florida Everglades and count the number of alligators. I did not manipulate the world of alligators before I went to count them. I am going to observe them. I'm not controlling the variables. I can write things down about what I'm doing while I'm out there, what kind of weather it is, how well I can see from the airboat. But essentially, I'm going to observe animals. And this is the kind of work that is common if you go into the wildlife and fisheries field. If you make observations of human populations without controlling things in an experiment, you make observations and conclusions based on what you see. And it's one way to use statistics. The rules are kind of different for these two. Observational studies, because they're not created by us, they're not controlled, well, they take a lot more rigorous statistics to make conclusions. So, in an experimental study, the study has two basic parts. Okay. One part is a controlled manipulation, which means a forced change, manipulation of a variable. Okay, that's one part that it needs. And secondly, the measurement. You guys are doing good. I'm going to leave them up here so we can catch up if you're behind. And the measurement of an outcome. Okay. In an experiment, we have more control. We manipulate one of the variables in the experiment, and we measure an outcome. And here comes a science term. Scientists have a hypothesis. Oh boy, hypothesis. A hypothesis when they start. Okay. Scientists have a hypothesis when they start. They guess on how the study is going to turn out. A hypothesis is an educated guess. So they start an experiment. They have a lot of control over a variable. Then they measure an outcome. And they have a hypothesis when they start. They guess on what result they're going to see. And then they use statistics to see if the result did indeed happen. You can publish your study whether it happened or not. But the most elegant experiments out there get the outcome they think is going to happen and prove it with statistics. So they have a hypothesis when they start. And this will help you in IPC or biology or chemistry this year because I am sure you guys talk about experiments. We measure an outcome. Who knew that math models had measurement of things, had statistics, had a crossover with science? Today we are. Okay, that is definitions for you. Let me zoom back out. At the end, I'm going to bring these back up. I'm making a video, so I want to go to a couple examples, and then I will bring these back up for those of you in class. So I'm going to turn my paper over, and I see 1 through 6 examples where I'm going to try to read this narrative and figure out what they're talking about. Is this an observational or an experimental study? So instructions at the top say answer 1 through, oops, that's an error, 1 through 6 with study type, observational or experimental. All right, let me pick around here. I like number 2. Let's look at number 2. Let me read it to you. A recent study showed that a new vaccine may be useful for preventing childhood diseases. Children were randomly assigned to either a group that received a placebo, which is a sugar pill and not a medicine, or to a group that received the new vaccine at the start of the 12-week study. A rate of disease infection was significantly lower for the children receiving the vaccine than the placebo. Okay. The variable here is vaccine or placebo. So scientists controlled this experiment by deciding randomly whether children would get a vaccine or a sugar pill. And you can put this down here. A sugar pill, a placebo is literally that. It is a small pill that looks like the true medicine, but is just sugar. It does not have the medicine in it. Because the scientists controlled the variable, this is experimental. That is an experiment. They had lots of kids in the study. They randomly assigned them to either a group that received the vaccine or a group that thought they did but did not. And then they measured an outcome, which is whether the children were infected or not during this course of the 12-week study. So this is experimental. I'm going to contrast that with the next one, number 3. A survey of over 7,000 randomly selected employees in 15 nations recently showed that employees who work in a digital workplace tended to be happier than those who don't work in a digital workplace. Now, this was done before the pandemic. It is a real study. They found that people that worked on their computer all day from home were happier than those that worked maybe outside or somewhere else. That was what these people found. So what do you guys think? Was it an experiment or an observation?
Observation. No.
Very good. This one is observational. Now, it does say they randomly selected people from 15 nations. They can make conclusions that are international in their scope.
You can get paid, right?
You can absolutely get paid to collect data like that and to participate in the study. People do get paid for that.
What was the first one? I was still right in front of it.
The first one is experimental on number 2, and 3 is observational. Now, the variable they measure, tended to be happy, right? It's some measure of happiness. A measure of happiness. I don't know how you measure happiness. Maybe on a scale between 1 and 10. But they did not control the situation. They didn't have 2 groups that were separate. They cannot make the same conclusions that you can from an experiment because those people were already in the workplace and had a digital job. So this one was not controlled by a scientist. It is observational. All right. Now, there's more to do here. There's 4 more questions, and I'm going to turn the notes page back over in a second. Here in class today, we are going to be finishing this page and moving on to a new piece with a break. So I'm going to end the video here, and we will pick up with one more pretty soon.